going to continue with the second part of the vector value function, that is we have the line integrals and apa nama dia, the Green's theorem. Okay, so yesterday kita dah tengok in this part we are going to learn about line integrals. Conservative vector fields tu tak ada, nanti we will just omit that apa nama dia particular part. And then Green's theorem, surface integral, Gauss theorems and Stokes theorem. Okay. So for line integral, kita dah tengok go through this example, the line integral, how you are going to find the what we call it, the parametric equation, the integration over the curve C for the vector function. Okay. And then we have also go through this exercise. If you have your curve goes from downward to the upward, so it will anti-clockwise. So you are going to have the positive value for the integration on the given curve. Okay. And then if we do the reversal of the orientation, meaning that rather than having the anti-clockwise, your curve is moved from upward to downward, so it will follow the clockwise rotation. And in this case, if we do the integration, you will get a negative value, which associate with the what we call it, with the orientation of the curve. Okay, so we have go through this exercise, and then this is for the case if you have the piecewise smooth curve, meaning that you have a few curves that connected to each other. So rather than having one shot of the integration over the curve, we do the integration pieces by pieces by finding the integration over C1, curve 1, curve 2 and up until curve 3. Okay, so this is the integration, and then this is all of this is for the case of scalar function. And we have go through this one if you have for the case of vector function. So the vector notation for the line integral will be equal to taking the integration over the vector function f, having the dot product with dr, okay, the derivative of the vector function. It will be equal to taking the integration from a to b, the vector function f, substitute the equation of xt, yt, dr over dt multiply with dt. Okay, so this is the vector notation for the line integral. Okay, so we have go through this exercise in how you are going to find the work done for the given vector function. Okay, so the next one we are going to have the extended the vector notation for line integral for 3-dimension space. Okay, so this one we have go through this exercise as well, this example, and you can go through this we have go through this exercise as well. So these two exercise you can do that one. So kalau awak tengok the next one, kita ada the line integral, independent part, the fundamental of line integral. So yang ini tak masuk okay. That is the conservative vector field. So yang ini tak ada, boleh just apa nama dia, slash from your slides. Okay, so do this one. Okay, exercise. Yang ini sebenarnya kepada piecewise tadilah. You find from 1 to 1. So this one tak ada. Kita tengok. Okay, so yang ini exercise juga. Dia sama dengan this one. Okay, dia sama dengan this one. You want to find the integration for vector f dr. So this is another exercise. Actually, you can just find the solution. X equal to t, y equal to t. And then that one, you get the answer is equal to 1. This is another exercise actually related to the vector function. Integration of the vector function. So yang ini tak ada. Conservative vector fields. This one tak ada. Awak boleh potong saja. Slide number 29, 29, 30 and 31. Okay. Okay, this one also tak ada juga. This one. So we have take a look into the next theorem. The conservative vector fields tak masuk dalam final, and it is also out of the syllabus. Okay. So from here kita ada this one. If f, vector f is the gradient of the function given that phi in terms of equation of xy in some open region, then vector f is said to be conservative in that region. Okay, so this is conservative vector field. Kalau awak nak tengok boleh lah, but it is actually tak masuk sebab even if you do the integration over vector f multiply with dr, this one will be equal to 0 for every piecewise smooth closed curve in the region. Okay. So there ada beberapa type of curve. A plane that is r equal to rt, a taking the value, a t taking the value between a to b, it is said to be simple if it does not intersect itself anywhere between its endpoints. Okay. So this is not simple and closed. This is if you have a closed curve, and this is if you have closed but simple, closed curve but simple, closed curve but not simple, because you have the curve tend to be having a few bentuk, okay, a few shape. So for this one, for the first one yang ini, so for the first one boleh dapat satu, dua curve sahaja. Kalau awak nak cari tadi integration over the curve C equal to C1 plus C2. But for this one, it will be very tedious because you have one curve to be like this, one curve to be like this, and then the remaining will be like this. Okay, so it is closed curve but not simple. And this one, if you have a simple and closed curve. Okay, so from here, this is the type of region. Plane region whose boundary consists of one simple closed curve, it is called simple connected curve. So for example, the first one, this is not a simply connected since the boundary consists of two simple closed curve. Okay? And this is not simply connected since the boundary consists of three simple closed curve, and this one is a very simply connected curve. So kita ada integration terhadap curve. You have integration over the curve of C. So we want to find the integration over this curve. You are going to have a one here, one there, and that one. Okay. So simply connected region cannot consist of two or more separate pieces and cannot contain any hole. So for this one, memang agak payah for you to find the integration because there is a two hole over here. Okay. Tapi kita tak tengok up until that level lah. Kita tengok yang simply connected punya. Okay. So macam previous example. So that is about the type of curve or the piecewise curve that normally involved in finding the integration or the area inside the curve. Okay. So kalau awak tengok, if we take a look into the previous one, so the calculation is a bit tedious because awak kena dapatkan integration over the vector function multiply with dr, that is the derivative of the vector function. So since it is very tedious, kita akan change that one to become much more simple by using the Green's theorem. So sekejap saya nak change kepada iPad. Okay. Okay, so if we take a look into the previous one, Sekejap seterusnya. Oh gosh. Okay, so kalau kita tengok untuk this example, okay, untuk this one previously, daripada line integral, dia tunjukkan kalau awak nak dapatkan dia punya integration for the given vector function, dia punya work done, for example, for this one, you have this kind of theory, okay. So, the integration over the curve f, this one, okay, it will be equal to integration over the curve C f dr, okay, equal to equal to integration of f x t y t r prime t. So banyak benda kan awak kena gantikan dalam equation, dapatkan dr, then dapatkan vector f. So from here the Green's theorem, okay, bagi the alternative, okay, Green's theorem dia bagi alternative for this case. So let's take a look into the Green's theorem. Okay, so this is the Green's theorems. Kenapa Green? Because nama orang yang jumpa this theorem ada maybe Robert Green, something like that. That is why there is the name of this theorem is Green theorem, not because of hijau. Okay, so let R be a simply connected plane region whose boundary is a simple closed piecewise smooth curve C oriented counterclockwise. So if fxy and gxy have continuous first partial derivative on some open set containing R, the region R, then integration over the curve C fxy dx, okay, plus gxy dy equal to taking double integral over the region R, delta g over delta x minus delta f over delta y. This is taking the partial derivative, okay, dA. So dA, this one can be dx dy or dy dx. That is your dA, okay. And if this one for the case of scalar, okay, for scalar function, and this one if f is a vector function. So this is the integration for the vector case. Okay. If fxy equal to fxyi plus gxyj, then integration over the curve C fr prime t equal to taking the double integral and then same this one taking the partial derivative with respect to dA. Okay, this one can be dx dy or dy dx, the same as before. Okay. So sama, dia jadi lagi simple. Awak just ambil partial derivative and then dapatkan dia punya double integral terhadap region dia and then terus dapatkan dia punya integration. Okay. So tu je. Dia tak payah nak gantikan dengan xt, yt, find the first derivative of vector r and then buat dia punya dot products. Okay. So Green's theorems give you an alternative for this one. This one is actually f dot dr. So Green is theorem is actually alternative to line integral in a much more simple way. Dapat semua?
Apa tu?
Alright. So nak salin dulu boleh salin. The next one saya tunjukkan how to do the calculation by using the Green's theorem. Done. This one.
Done tu.
Oh. So let's take a look into so the Green's theorem gives us a way of evaluating the line integral of a smooth vector field around a simple closed curve. Okay. So for example, a simple closed curve. Okay. So a way of evaluating, meaning that it's just an alternative for evaluate the line integral of a smooth vector field. Okay. So use Green theorem to evaluate integration over the curve C x squared y dx. Okay. Okay. X squared y dx plus x dy over the triangular path shown in the figure below. So if you take a look at this question, awak ada dx dy. So kita tahu yang ini integration yang you nak cari either using line integral or you want to find the or using Green's theorem. Okay, soalan suruh guna Green's theorem and integration over the curve C. Yang mana ianya sebenarnya adalah integration over the curve C x squared y dx plus integration over the curve C x dy. Okay. So dia suruh dapatkan over the triangular path shows in figure below. So this is titik 1, yang ini titik dia adalah 2. Macam mana kita nak guna this one to solve, how we are going to solve this one by using the Green's theorem. So tengok balik apa yang Green's theorem cakap. Okay, first thing first. Yang ini adalah garisan X sama dengan 1. And what about this line? Apa equation untuk garisan ni? Kalau awak tengok bila X sama dengan 1, Y sama dengan 2. So Y sama dengan MX plus C. So dia punya pintasan dekat sini. That is kosong. So kecerunan dia berapa? 1.12 lagi 1.01. So M sama dengan X2 tolak X1 divide by X. Y2 tolak Y1. X ke Y? Y2 tolak Y1 bahagi X2 tolak X1. Something like this lah. Y2 minus Y1 divided by X2 minus X1. Okay. So apakah garisan? This one. Garisan yang saya tandakan merah ni. Ada yang dapat tak? Equation for the line. Yang ini masa darjah berapa dulu dah belajar? Tingkatan 3 kot. Coki dah belajar. Mana dapat? So equation for this one, kalau awak gantikan, dia akan dapat M akan sama dengan titik dia 1, 2 dan juga 0, 0. So if you substitute in here, Y2 tolak Y1. 0 bahagi dengan 1 tolak 0. Dapat 2X. So equation this one is Y sama dengan 2X. Dapat And kalau tengok dia punya rotation is this one. Okay. Daripada situ ke situ. Okay. Positive because this one is anti-clockwise. So by using Green's theorem, okay. So by using Green's theorem, kita ada integration over the curve C f of xy dx plus g of xy dy. This one akan sama dengan integration over the bounded region R delta G over delta X minus delta F over delta Y dE. Okay. Dan daripada equation yang dia bagi, tengok balik. So kita akan dapat this is the line of Y sama dengan 2X. So ni adalah dia punya rotation. So daripada equation yang dia bagi, compare. So ini adalah fxy and this one is your gxy. So compare the equation. Akan dapat f of xy sama dengan x kuasa 2 y. G xy sama dengan x. Okay. So dapatkan partial derivative for that one. So delta f over delta x dapat apa? Okay. Delta g over delta x. So dapatkan delta g over delta x dan juga delta f over delta y. So dapat apa dia punya partial derivative? Okey, bezakan x squared y terhadap this one, delta g terhadap delta x. Terbalik dah pula saya tulis tu. This one. Delta g terhadap delta x, bezakan dapat apa? Hui, ada orang tak tahu? Bezakan x squared y terhadap y. Akan dapat x squared. Dia ni lah. Delta f terhadap delta y. Okay. Delta f over delta y akan dapat sama dengan x squared. Okay. Delta g over delta x akan dapat sama dengan 1. Okay. So, masukkan these two information in here. Okay. So, daripada situ, substitute in there by using the Green's theorem. Okay. By using Green's theorem, integration, this will be equal to integration over the bounded region R. Delta G over delta X is 1 tolak X kuasa 2 dA. Okay. So dA, this one is ikutlah awak nak gerakkan daripada atas ke bawah atau kiri ke kanan. Let's say saya gerakkan daripada bawah ke atas first. Okay. And then kiri ke kanan. This is the second movement. So that is the first movement and this is the second movement. Ni yang first, ini yang kedua. So from that one kita dapat integration, kalau first one 1 tolak X kuasa 2. This is for type 1, that is daripada kosong sampai garisan 2X dx. Yang kedua daripada kosong sampai 1 dy dx. Okay. So it will be equal to 0 1 y tolak y x squared 0 2x dx. Integration kosong 1 2x tolak 2x kuasa 3 dx. Okay. So settlekan akan dapat 2x kuasa 2 per 2 tolak 2x kuasa 4 per 4. 0, 1. So dapatlah jawapan dia. 1 per 2. Dapat Yang lain? This is the integration by using Green's theorem. So jauh lebih mudah daripada guna line integral. Awak tak payah nak dapatkan apa nama dia 1 per 1 dia punya apa nama dia? Dia punya derivative, lepas tu nak kena buat dot product lagi, nak kena buat apa nama dia, nak tentukan dia punya region. So by using Green's theorem it is much more easier. Okay. Nampak Any question so far? Megat, okay Megat? Okay. Fahim okay? Faris Irsyad, Firas. Dapat tak?
Dapat, Doktor.
Okay. Saya terpaksa je jawab. Marah ke tu?
Tak ada tu.
Helen, okay? So by using Green's theorem, it is much more easier compared to line integral. Tapi kena tengoklah sebab kadang-kadang ada soalan yang minta using line integral as well. But some of the question it should be fine by using the Green's theorem. Okay, Nelly, okay?
Okay, doktor.
Alright. Yang dia punya region of the integration tu daripada apa yang kita belajar dalam chapter 2. Okay, yang awal-awal dulu, double integral. So we have to make use of that information and dapatkan dia punya line integral. Okay. Okay, done. This one.
Dan
Done. Right. So let's take a look into another example. Okay. This one involving the vector function. Okay. Find the work done by the force field. So ni satu cara juga nak tulis vector. Kita boleh gunakan this one, which is actually this is a vector function sebab f dia adalah dia boldkan. So this is vector. Yang mana vektor dia sebenarnya adalah f x y sama dengan exponential of x minus y kuasa 3 I plus cos y tambah x kuasa 3 j. Okay. So itu adalah vector function on a particle that travel once around the unit circle x squared plus y squared. So tengok soalan dia, dia cakap around the unit circle x squared plus y squared equal to 1 in the counterclockwise direction. So kalau kita lukis x squared plus y squared sama dengan 1, dia bergerak dalam satu bulatan, this one, negatif 1 and 1, dia punya radius, dan counterclockwise direction. So melawan arah jam. So this is your x and this is your y. So this is equation of x squared plus y squared equal to 1. Okay. So work done is actually equal to integration over the curve C f dot dr. So kita akan use Green's theorem to calculate the work. Okay. So by using Green's theorems, the state kita pelajari dulu. Dan belum.
Dah doktor.
Okay. So sekarang minggu ke 14, 13, minggu ke 12 ni. Supposingly. Exam awak, paper awak 24. Study week pun dia anjak jadi sikit. Okay. So, the work done. W equal to integration over the curve C f dot dr. That is equal to integration over the region delta G over delta X minus delta F over delta Y. Okay, dA. So awak punya vector F X Y equal to cos Y exponential X. Okay. Exponential X minus Y cube I. Okay. Plus cos Y plus X cube J. So ini adalah vector F. So daripada sini dapatkan your F function and also your G function. Okay. So daripada sini yang ini adalah F awak. Okay. Fxyi. So kita tengok balik kepada this one. Okay. If F equal to Fxyi, this one. Okay. If F equal to Fxyi, F prime dg over dx. So yang ada I akan jadi G, yang ada I adalah awak punya F. So this is your F of xy and this is your G of xy. Okay. So Fxy equal to exponential x minus y cube. So delta F over delta Y equal to negatif 3 Y kuasa 2. Sebab kita nak dapatkan this one. Delta F over delta Y. Okay. And then G XY. G XY equal to cos Y tambah X cube. Okay. Delta G. Okay. Delta G over delta X equal to 3X kuasa 2. Okay. So daripada sini masukkan these two information, okay, delta G over delta X ke dalam the Green's theorem. Okay. And then kita punya region tadi adalah dalam bentuk bulatan. Okay. Region kita is in term of bulatan. Okay. That is this one. Negatif 1 and 1 and it move counterclockwise. Okay, by using Green's theorem, integration, it will be integration over the bounded region R, delta G over delta X minus delta F over delta Y dA equal to integration over the bounded region R, delta G is 3X kuasa 2 tolak negatif 3Y kuasa 2 dA. Okay. it will be equal to integration over the bounded region R 3x squared plus 3y squared dA. Okay, so dia ada dalam bentuk circle. Okay, in circle. So senang using cylindrical coordinate. Okay, so dapatkan apakah awak punya R and what is your theta. So senang, integration 3x squared tambah, it will become integration of 3x squared plus y squared dr d theta. Okay, r dr d theta. So daripada rajah, boundary bagi r daripada berapa ke berapa? Okay, from here r daripada berapa ke berapa, theta daripada berapa ke berapa.
R0 ke 1.
Okay,
Theta 0 ke 2 pi.
dapat S apa? Done kelas?
Done.
Ya, ada soalan tak so far? Dia kena define mana awak punya f vector function, g function, and then dapatkan dia punya partial derivative, and then dapatkan all the derivative of the vector function. Lag lagi ke Sang? Tak kan? Tadi yang lag, Faris.
Tadi. Dah okey dah.
Oh, okay. So dah yang ni semua. So kita tengok kepada the next one. Kita ada yang ini. Ini tak ni. Tak payah tengok sebab dia tak ada apa pun. The important thing yang awak kena tahu is the green theorem. So this one is not include. Okay. Yep, for this one. So kita terus tengok another example because that one is actually it's the green theorem, just how dia rombak balik the green theorem. Okay. So let's take a look into this example. Okay. By using green theorem, evaluate integration over the curve C negative y dx plus y plus x dy where C is given as in the figure. Okay. So awak ada C adalah anti-clockwise rotation daripada 1 ke negatif 1, it rotates on the line of y sama dengan 1 tolak x squared. So this one sebenarnya y kuasa 2 sama dengan 1 tolak x squared atau y kuasa 2 plus x squared sama dengan 1. So dia sebenarnya adalah half bulatan. Okay. So soalan suruh gunakan Green's theorem to evaluate the integration of this function. Okay. So tengok dekat sini minus y dx x dy. So from here, sekejap So if you are using this one, by using Green's theorem, kita ada integration over the curve C, over the curve C of the function okay, it will be equal to integration over the bounded region R delta G over delta X, okay, minus delta F over delta Y dA. So from here, awak punya F function sama dengan negative Y. Okay. And G, X, Y awak adalah sama dengan X. So dapatkan delta F over delta Y and delta G over delta Y. So tentukan dia punya region. Then kita nak masukkan dalam this one. Cuba buat sekejap. Saya nak pergi toilet. Okay, dapat tak kelas? So partial derivative for this one with respect to y akan sama dengan negatif 1. And delta g over delta x. Okay, not delta y. For this one akan dapat sama dengan 1. Okay. And delta a. So since the what we call it the area is half circle, so it will be easy using cylindrical coordinates. Okay, so cylindrical coordinate awak ada yang ini awak punya r, okay, and then you have your theta. So this is r and this is your theta. So r daripada berapa ke berapa, theta from where to where? Anyone? Dapat r dari berapa ke berapa, theta dari berapa ke berapa? Suhaib, berapa M? Suhaib pula. Suhaib. Amirul Fazlin, Faizin, Amirul Faizin. Fahim. R dari berapa ke berapa? Theta dari berapa ke berapa?
Ada tengok.
R01.
Perempuan juga yang bagus. Okay. Theta.
Kosong pi ke?
Yep, betul. Okay, woman always right. Inilah terbukti. Theorem tu. Okay. So 0, 1 untuk R and 0 sampai pi for theta. So dia akan jadi sama dengan 0, 1 integrate 0 kepada pi. Yang ini dah tak slide ni. Saya nak buat dekat sebelah lah. Dia punya solution. Cuba buat. Masukkan dalam this one. Dia punya integration. dr d theta. So it will be integrate 0 kepada 1, 0 kepada pi. Delta G is 1 tolak negatif 1 didarabkan dengan R dr d theta. So 1 tambah 1, 2 integrate 0, 1, 0 pi R dr d theta. R kuasa 2 per 2, 0, 1. Terbalik lah. 0, 1, 0 pi. Okay. D theta. So settlekan, dapat jawapan dia pi. So saya skip dia punya step tu supaya awak settlekan sendiri the integration. You will get the answer equal to pi. Done?
Done.
Dapat jawapan dia sama dengan pi.
Dapat.
Okay, kita tengok the next example. Okay, kita ada dua example. We will go through this example one by one. Okay. Evaluate integration over the curve 3x squared minus y squared dx plus x dy, where c is circle x squared plus y squared sama dengan 9. So, saya tulis dekat sini lah. Example. Okay. We want to integrate over c x squared minus y squared dx plus x dy, where c is circle of x squared plus y squared sama dengan 9. Okay. So, dia punya solution by using Green's theorem, okay, it will be equal to integration over the bounded region R, delta G over delta X minus delta F over delta Y dA. Okay. So this is your X dx. This is your, another one is X dy. So from the given equation, F of XY awak adalah sama dengan x squared minus y squared. Okay. G xy sama dengan x. So dapatkan delta f over delta y, delta g over delta x. Apa jawapan dia for this one? And then dia kata C circle of x squared plus y squared sama dengan 9. So this is C. Okay. Circle, so senang guna cylindrical coordinate. Cuba buat bagi saya apa jawapan akhir. So I'm waiting for your final answer. Okay, dah dapat. Depan. Okay, kalau kita masukkan dekat dalam ni, the same as previous one. Okay, so yang ini adalah theta. This is your R. So for this one, R is between 0 to 3. Theta akan sama dengan 0 sampai 2 pi. So dia sama je dengan example yang tadi. So the integration over the curve C x squared minus y squared dx plus x dy equal to integration from 0 to 2 pi 0 to 1. So delta G minus delta X, this one akan dapat 1. This one dapat negatif 2 Y. So it will be 1 tolak 2 Y R dr d theta. Okay. R dr d theta. 0 sampai 2 pi. Okay. 2 Y. So Y sama dengan R sin theta. Substitute in there. 0 sampai Y. 1 tolak 2 R sin theta. R dr d theta. 0 to 2 pi.
Limit yang R tu 0 until 3.
Oh, okay. Salah. Selamat beritahu. 0 to 3.
Memang 1 tolak 2 Y.
1 tolak 2Y. 1 tambah 2Y. 1 tolak negatif. Bagus juga bila saya buat banyak silap. Okay, 1 tolak 2Y. That means 1 tambah 2Y. So, thank you. Okay. So, jadi 1 tambah 2R sin theta. So, dia jadi R plus 2R squared sin theta dr d theta. 0 to 2 pi R kuasa 2 per 2 tambah 2R kuasa 3 per 3 sin theta 0 to 3 d theta. Okay. Sama dengan 0 kepada 2 pi 9 per 2 tambah 3 kali 3, 9 kali 3, 27 kali 2, 54 bahagi 3. 3 kali 1, 3, 18. Okay. Tambah 18 sin theta, d theta. So, dapat 9 per 2 theta tambah 18 minus. It will become minus. Integrate sin minus cos. Minus 18 cos theta 0, 2 pi. Sama dengan 9 pi tolak 18 tolak 0 minus 18. Kosong kena gantikan sebab cos kosong sama dengan 1. That's why kena gantikan. Cos kosong sama dengan 1. So, dapat jawapan akhir sama dengan 9 pi atau 28.2743. So dapat
Dapat ada.
Okay. Okay, yang dah cuba buat ada lagi satu exercise. The last one. Okay. Evaluate exponential squared plus y squared plus exponential y plus x squared. Cuba buat yang tu. Where C is the boundary of the region y equal to x squared and y sama dengan x. So this one is a bit different. Cuba tu lukis dulu curve dia macam mana. Y sama dengan x squared dan y sama dengan x. So yang dah cuba buat another exercise. Okay. The last one. Evaluate integration over the curve C exponential 2 tambah y squared dx tambah exponential y tambah x squared dx. Okay. Where C is boundary of the region y sama dengan x squared and y sama dengan x. Okay. And y sama dengan x. Okay. So cuba buat this one. lukis dahulu the boundary. So we have y sama dengan x squared dan y sama dengan x. So if you want to do the drawing for this one, okay, get this is y equal to x and ini adalah garisan y sama dengan x kuasa 2, x dan juga y. Okay, so dekat sini dia punya pintasan adalah titik 1, 1. Okay. So daripada y sama dengan x kuasa 2, dia goes kepada y sama dengan x. So garisan dia to be like that. So ini adalah dia punya close region. Okay. So this is your F and this is your G. So F of xy equal to exponential 2 plus y squared. G xy sama dengan exponential y tambah x squared. So delta F over delta y. Then delta G over delta X. Dapatkan dia punya partial derivative. What will you have for this one? Okay, dapat. So delta F over delta G akan dapat bezakan terhadap F terhadap Y akan dapat 2Y. So exponential 2, this one is a constant. Okay. So ni adalah constant. Okay. And then delta G terhadap delta X dapat 2X. Okay. It will be equal to integration over the bounded region R 2X tolak 2Y dA. So dA ni refer kepada rajah awak. Katakan saya ambil gerakan atas ke bawah first, then kiri ke kanan. Okay. So Y daripada berapa ke berapa? Dia punya boundary. Dan X daripada berapa ke berapa? So Y dari berapa ke berapa? Kalau dia tengok rajah tu, dia akan bertemu garisan X squared and then garisan X. So Y will be from X squared sampai X. X pula daripada 0 sampai 1. So substitute in here 0 to 1 daripada X squared sampai X. 2X tolak 2Y dy dx. So 0 to 1, 2xy minus 2y kuasa 2 per 2. X squared sampai x dx. Okay, 0 to 1, 2x kuasa 2 tolak x kuasa 2. Okay, ditolak dengan 2x kuasa 2 tolak x kuasa 4 dx. Okay. So integrate from 0 to 1, x squared minus 2x cubed plus x kuasa 4 dx. So integration for this one, x cubed over 3 minus 2x kuasa 4 over 4 plus x kuasa 5 over 5. 0 to 1. So gantikan dapat 1/3 tolak 1/2 tambah 1/5. Tolak 0. Dapat 1/30. Dapat So then ada exercise yang saya letak dekat dalam tu, tapi saya pun tak ada dia punya final answer. So awak boleh try lah sendiri by yourself. Okay. So later on nanti insyaAllah kalau ada masa lagi kita akan buat more exercise before your final exam. Okay, soalan tak so far for the green theorem. The next one kita akan ada surface integral, Stokes theorem, the Gauss theorem, Stokes theorem or Gauss theorem. Stokes theorem and then divergence or Gauss theorem. Dapat Hui.
Dapat betul dapat.
Laju dia jawab betul-betul dapat. Okay. So from here we can see if we are using Green's theorem, it will be much more easier to do the integration for the curve C as compare to guna line integral. Kalau guna line integral, awak kena kira satu-satu, dapatkan dia punya what we call it dot products, okay, and then baru buat dia punya integration. So this one is much more simple, but you have to know how to determine the area of the integration, okay, the limit for the integration. So dapat Any question so far? Ada soalan kelas? Senyap je, tandanya tak ada.
Tak ada.
Okay. So far. So exam awak apa nama paper ni paper first 24 Januari. So yeah, that's it. All the best lah. Okay, that's it for today. Nanti recording saya akan letak dekat YouTube.